Hello. Are we live? Hello. Are we live? Hello. Are we live? Okay, that was a bad idea. Give me this one. Test. Let me check the time. Takes. Pink. Long. So 3 seconds. The delay. Okay. Okay, we got some comments. You're live. Thank you. To stop listening to myself. Okay, let's test these buttons. Okay. Desktop. And yes, I see desktop. And that was okay. So we got some time. I'll be back. I'll be right back. Hello. Okay, Discords, can you hear me? Can anyone confirm? Okay, great. Oh, it's working. Oh boy. This one's working, so stream is running. If you wanna watch, because I'll probably draw something, I don't know, I'll see. I'm gonna use it. And I can use it, reuse it later so that you can watch it back later. Maybe not you. Okay, let's try to ping people. Let me just warn people to join the stream, like the revision. Where did I write it? Here we go. Yeah, it's a lot of people. Hello everyone, welcome. Okay, some rules, just make sure you're muted or you have push to talk. And can you use questions or discussion channel? Can anyone try to use them? In the physics revision, obviously. Okay. Lily, are you here?
minute late.
No, it's totally fine. Is it possible to somehow reopen the questions or discussion channel?
Is it possible to what?
Questions and discussion channel, people cannot use them because they don't have permission. Is it possible to open them?
I don't have permission to edit them, but I will contact someone to sort it out, sorry.
That's okay. I mean, we probably don't have to, we probably can reuse some other channel if that's a big problem.
I mean, we can just use the physics one for now.
I mean, physics one, I don't really want to spam it because everyone's going to use it for questions and all that kind of stuff, so usual people can actually use it. We might reuse, for example, the muted revision one because no one's there right now anyway. Right? Yeah, okay. Last match like 3 hours ago. So
everyone cannot see or cannot write or both?
Cannot write.
Okay, thanks.
So I could use it, so for me, like, I have no clue. Yo, so many people. Let me count.
Hello.
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 Can you send messages now?
Yep.
Yeah.
All right.
Thank you so much. Thank you.
Thank you. Yes.
Yeah. Enjoy, you applied math nerds.
Thanks. Oh, more than 20 people. 30 maybe.
Okay, just quickly, if anyone is annoying with noise and stuff or forgets to mute, I will just mute them. Just so it's more productive, just saying that.
Perfect, thank you. Okay,
what a savage.
Give me 5 minutes, I'll get some water and then we can start. People will join anyway for now.
Yeah, good.
So, how many of you just started studying for physics?
Me.
Hell yeah.
Of course.
It's okay. It's like one of the easiest subjects, there is an IB.
Didn't we start 2 years ago?
What?
I started 1 day ago.
About an hour.
It's okay. If you're SL, you should be fine.
Okay, and if you're not?
Pray for
I mean,
the
I
best.
got a 7 and 2 1s on the mocks. I was lucky that I remembered that the previous, it was a recycled test.
Mocks don't mean anything anymore.
I think grades in general don't mean anything.
Don't put people down here.
Come on, we're physics students. It's the real life.
Yeah, mocks don't mean anything, though. That's true.
Oh boy. Yes, so I have the stream up and running. I'll probably show some stuff there, so I guess you can open it if you really want to. Remember that anything you say will be recorded on the stream, so let's try to keep it nice. And I actually have no freaking clue how we're gonna do it, so I can just go through the same slides, but I'm not sure if that's much point, so I'll just do a small survey. So I'll just ask you to vote whether you want me to go through the same slides or answer some questions. Let me just write that message. So questions or same slides. And you can vote with Q and S in important files and links. So either I'll just try to answer some questions and maybe go into detail in something, or I can go through the same slides, just try to say the same thing, even though it's all recorded already, and maybe someone wants to. It's majority chooses it. I can do it. Same for me. Yeah, I think questions win by the big margin. Okay, Then I guess we just need to ask questions. What else? Please use the questions channel. I don't think you should talk because there are quite a lot of you. So just begin with questions. I'll try to answer them one by one. Yeah, warning, I did not prepare as much as last time, so I might have to Google a lot and...
Don't
Okay.
worry, nobody prepared.
Yo, fair point.
That is true.
Topic 5, general tips. Draw, definitely draw. If you get a diagram or something like circuits, definitely draw. I mean, topic 5 is mostly like circuits, and there you need to know the rules of all the circuits and that kind of stuff. Yeah, okay, stream is up and running. Just checking. Electric fields, yeah, learn to identify how does electric field work. I don't even remember in ESL how much you need to know. Remember that electric field is defined for positive particles, not for negative ones, so not electrons.
Hey,
Yes.
I'm gonna go deaf and ping me if there's like some issue.
Of course. Oh boy, so many questions. And remember to use right hand rule. When are gluons the intermediate particle? Oh my goodness, so specific questions. I actually have no freaking clue. I'll be honest. I have no clue.
Strong nuclear force, right?
Yeah, that's strong nuclear force. Well, if you check the data booklet, you can see that they're both experiencing and meditating. I honestly don't remember learning it at all. So just Google. I haven't done quantum physics yet, so I cannot answer, sorry. Maybe
gluons are the intermediate particles for the strong force, so between quarks.
Yeah, but the question is when they are the one experiencing and when the one mediating. I mean, meditating. If anyone have the answer, yeah, okay, maybe someone wrote in the question something. No. Maybe we can go through past paper together. I did not really plan that yet. I'll see. Probably not, because I'll probably have enough questions. Either stream just records. Well, I'll probably try to show some stuff on the desktop if I have anything to show, like specific questions, for example. Because there'll be probably a lot of specific questions, and I'll probably be pretty bad at them. Okay, we have a question, and let me try to put it up to the stream because it's gonna be. And we press this button. Okay, can see it on the stream. Yes, we can see it on the stream. Okay, planet X and planet Y both emit radiation as black bodies. Planet X has a surface temperature that is less than the surface temperature of planet Y. What is the graph of the variation of intensity E with wavelength lambda for the radiation emitted by the planets Y? The graph for planet X is shown dotted. So we have two planets, black bodies, so X and Y, and X has a lower surface temperature. From the data booklet, we can find that the max wavelength is inversely proportional to the temperature. So basically, the top wavelength will be more to the left if it's higher temperature. And planet X has less temperature, so it's gonna be more to the right than planet Y. Since planet X is dotted, it's gonna be more to the right. And it's very important to remember that black body that has more temperature has a bigger graph in all wavelengths. Yeah, higher temperature, more graph, more intensity, I mean. So I think it's answer D, if I don't mistake. It's not A because the wavelength should be shorter. It's not B or C because it should be less. Oh wait, can you go over Kirchhoff's law things for calculations? Yes, Kirchhoff, please. Okay, let's do it. So let me find paints, because that's awesome. Let me find some kind of awesome question. It's gonna take a bit while. Oh, I can just steal it from my old slides and just find them. Slides, go to the slides. You don't see everything because I have second monitor. And that's this one. It's here. Clipboard doesn't contain one. Yes. It's not the best quality, but I hope you can see it. Yes. So this is Kirchhoff's law question. I'll say again what I said on the last revision, is that I haven't seen this question for like a long time. The only time I've seen it in new syllabus is May 16. Is it something that you should study then? Well, you haven't seen it in a long time, so maybe yes. It's a good question. It's both SL and HL, and here we have a circuit. We have 2 loops, and you can see my mouse at this time. So we have 2 loops. Technically, we can have 3 loops, and I'll do the loop, obviously, Kirchhoff law, because that's the one I like better. You can do the other one if you like it, but I'll go through this one. So first of all, we need to define, well, first we need to find the loops, and we can find these 2 loops. So I'll say this one and this loop. This one loop 1, this loop 2. Again, please watch the stream for the picture. I'm pretty sure you can see it. Double check. Yes, you can. Please speak up if you cannot see something. Or... Yes. Okay, let's continue with the loops before I get distracted too much. Then we need to identify currents for each loop, current direction. We can identify the current direction wrong because it's all abstract. We just get negative answer if it's wrong direction. And I already identified from the last time, from last revision, red and purple. So red, and which is red. So red goes in here, in this loop. And we can see this is minus and plus battery. So that's why I chose this direction. I could choose the other one. You'll actually find out that one of them I think is wrong. So that's totally okay. Then we have purple one that goes in another direction. Here, 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 and here. Minus plus. Okay, so now we need to write the equations for each of the loops. And let me use actual text because it's better. It's black. So we use for first loop, that's why I call it one, red one. So we need to start at one point and end at the same point. So easy enough. Let's start at the battery, like just before the battery. So we go from minus to plus, and we need to remember that when we go from minus to plus, we add voltage. So it's 28 volts. Then we come to the resistor R1. It's 4 ohms. And it's in the same direction as we move in our loop. So what does it mean it's in the same direction as we move in our loop? We move in our loop, it's clockwise, yes. And our current is also clockwise. So we move in the same direction as our current. So we get negative voltage. We get a voltage drop over resistor. If our current would be defined in other direction, we would get plus voltage. But in this case, it's negative because we move in the same direction as current. So minus 4, which is 4 ohms of resistor, times current 1. So I say 1. I call it I1 because I need to call it somehow. Okay, so we took care of this voltage drop. Then we come to the junction, but we don't care about junctions because it's potential, Kirchhoff's law. Then we come to second resistor, R2. And it's 2 ohms, so minus 2 times I1, like last time, in the same direction as current. However, we need to remember, we have the other current from the second loop going through the same resistor. In this case, the current is in the same direction as we move in the loop. So it's also minus 2 times I2, because it's second current. If the second current would be in the different direction, we will have to plus it. So, hope you can understand that why we have two currents, because we have two different currents moving it through the same resistor. It's same direction, so negative. We go back, we go to the starting point. So potential drop should be at the end 0. 2. We do the same thing with the second loop. We start, for example, at this point. So this point right here. Then we move in the same direction as our current because I like it. I could choose other direction, you will get the same answer. So first we come to the battery, 7 volts, because we go from negative to positive. Remember, small line is negative, a long line is positive. It's like two small minus signs that on top of each other, that's why it's plus. So to remember it yourself. First 7 volts, boom, 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 resistor R3. So we do minus because it's in the same direction as our loop. 1 ohm times I2 resistor. Then we go to the R2 resistor. And that's minus because it's same direction as we'll move in our loop. 2 times I2, 2 ohms times I2 current. And since we have current 1, which is red current, minus 2 times I1 equals 0. Now we have two equations, two unknown, so we can drop the V signs because because we don't care about units technically, because we know that all of them are voltages from the Ohm's law. So we have two equations, two unknowns, I1 and I2. So solve by your preferred method and get the answer, which was, and I'm gonna look it up because I don't want to solve right now. I1 equals 5 amps and I2 equals minus 1 amp. Yeah, I should write it as text, but it's okay. As we can see, our I2 is negative. What does it mean? It means that we chose the direction of our currents wrong. Should be other direction. So in reality, let me use some kind of orange color. In reality, our current goes in second loop as like this. And that's all. Okay. Hope that answers your question. Difference between electric field, electric force, magnetic field, magnetic force. Electric field, first start with electric force because that's easier. So electric force and magnetic force. Electric force comes from electric currents. So if I have, make a new one. That's a bit too small. So if we look again at the string picture, so for example we have positive charge, so it radiates, no, not radiates, it has a force. And now I'm drawing field lines, even though I said I would be drawing force. Yeah, I'm weird. Yeah, I should probably do that later. So we have positive particle. It can exert a force on, say, another positive particle, or let's use blue color, negative particle. So what does a force do? Well, it's like a gravitational force. We are attracted to Earth. However, in electrical case, it can be both attraction or repulsion. So we can use another color. And I got some kind of... The field lines does go out of the source node from centers. I'll get back to it. We have force of negative and positive charges. They attract because they're opposite charges. Force is literally force. They come together or repel, like Earth and us. So I am attracted to Earth, and Earth is attracted to me due to gravitational force. Easy enough. And if we have two positive charges, they repel because they're equal charge. So equals equal charges repel, opposite charges attract. Then we have okay, let's continue with the what was it? Excuse me. And yes, electric field. So let's delete the other particles, and that was a bit too much. So electric field, basically it shows in what direction we're gonna experience force if we have a test particle, positive test particle. So if I were to put some kind of positive particle right here, it would move in this direction along the electric field line. More electric field lines means stronger electric field. So if we have 8 of them, it means it can be, for example, 1 Newton per coulomb. If I double the amount of electric fields, it can say be 2 newtons per coulomb. The number is arbitrary, so I can draw 8 or 4 or whatever I want, just as long as I'm consistent when there are other charges. So if, for example, I have 2 positive charges, I need to draw double the amount that I had on 1 positive charge. And let's delete everything. And we have negative, obviously, then we attract. So positive charge, remember, electric field is defined for positive test particle. It would attract to negative charge. And from there we can get all beautiful graphs of it was a bad idea. Wait. And then we have positive, because positive charge would want to repel from positive to, positive test particle would want to repel from positive particle, and we want to come to negative particle. So we get this. That's why we get curved. And if positive was here, it cannot get to negative 1 unless it goes around, and it doesn't want to go around, so force is in that direction. Okay, easy enough. Now we get to magnetic force. Magnetic force is a bit different. It comes due to, say, magnets, permanent magnets. And now I'm gonna do a stupid mistake that I always forget is, where does it start, where does it end? If I don't mistake, it starts from north, ends on south, right? Yes. So yes. How do I remember it? Because on Earth, let's draw Earth, I know green, because even though it's mostly water, north is on the south pole, south is on the north pole, and it goes from north to south. Inside the magnet, it goes straight through. I don't remember if you need to know that for IB, but those interested, here we go, you know it now. The key here between the electric field of the particles and the magnetic field. Magnetic field does not have a starting or end position, because we cannot have a single magnet like that only has north pole. There is no such thing, well, at least yet we have not observed it yet. So we always have a start position and end position. I mean, we never have start position and end position. We always have continuous loop. That's why we have these magnetic field lines in the center through the magnetic field, through the magnet, I mean. What's the other difference between magnetic field and electric field? If you put a particle right here, it doesn't mean that it will go along this one. No, because our force is defined as QVB sine theta. So first of all, the magnetic force depends on the velocity. Secondly, the force, I mean the vector where it points, is completely different to the field. It's at the right angles, and it depends where the actual velocity is. So velocity is along, use out of color. So velocity is along the magnetic field. The sine angle is 0, so it doesn't experience any force. Unlike the electric fields, where it experiences no matter the angle and no matter the velocity. And when the velocity is 0, the electric force due to electric field is always there. How do you find the at what angle, like at what position, at what direction is our force, magnetic force experience? Right hand rule that I'm also gonna steal from my old presentation. Oh boy. And but here we go. Not best quality, but you can see it. So moving charge is one direction, magnetic field line is another direction, and our thumb shows the force. So if we have magnetic field that points down, let me draw it, and we have a particle that enters like this, its path will be determined, well, first of all, on the charge of the particle, but secondly on the velocity. So let's try to point it. All your middle finger and other fingers go down into the paper. Your velocity points to the right. So where does your thumb point? Up. So our particle will go like this. Since it has initial velocity, it won't momentarily shift. So if I show the force arrows, it will be always at right angles to both magnetic field and the velocity vector. How did I know that the magnetic field is down? Well, because it's crosses. Crosses, like what I've learned, is it's like arrows. So when arrows fly away from you, you see like crosses. When they come towards you, it's like dots. They usually specify in IB questions, but it's good to know which one's which. So this one is to you, this one is into the paper. So it gives some interesting consequences. So we have a magnetic field that goes like this, so that's magnetic field, and our particle moves, say, like this. Then the magnetic force will be 0. Even though magnetic field is there, they are parallel. Velocity and magnetic field are parallel, so force is 0. So no matter like this, it's parallel. It's 0 then. And that's pretty much the biggest difference. I mean, you can pose the question, I'll just get to it much later. It's totally okay. Yes, when do you know it's strong? Just because its force isn't an answer. I mean, it depends on which particles interact. That's all I remember, honestly. I don't want to go into it. I know for sure that strong is when we have a nucleus, and obviously we have electric force. And where's my mouse? It's on the screen. So if I delete everything here, and please, thank you. So physicists thought that if a nucleus is made out of positive particles, excuse me, and they're all together, and there's strong electromagnetic force that tries to repel them, then something has to keep them together, otherwise they would be repelled. And that's the strong electromagnetic, no, it's strong force, before I say anything wrong. It's strong force that keeps them together. But also neutrons, and I'll just draw them as blue because why not, play a role there, because they usually not linear but approximately linear increase of protons and neutrons as particles get bigger and bigger. So to uranium you don't have like 50-50 electron and neutrons and protons, but about like 60-40. I don't remember honestly the number. And the weak, yeah, it's weak force. Well, it's usually during decay, but okay, honestly, just Google it. I don't want to lie right now because you have exam tomorrow, and then someone will come after like they get the results. Oh, you lied to me, and it was not due to that and that. Strong is neutrons important, yeah, that's for sure. I don't want to lie, I'm not gonna say. What do you mean strong? Strong nuclear interaction, yes. Weak involves a decay as well, yes. If you answer questions between yourself, please use discussion chill because I'm gonna read it all and yes, it just takes more time. Yeah, thank you, Lila. Sorry, too late. Never mind. Okay. In nuclear fission, a nucleus of element X absorbs a neutron to give a nucleus of element Y and nucleus of element Z. What's the magnitude of the... oh my goodness. What's the magnitude of the binding energy per nucleon of one divided by another and total binding energy divided by another? Yes. Let's try to figure it out. That's definitely not the easiest question. No, let's try. Can I copy it? I can only copy the link. Let's use this one. Okay, good enough. So we have some kind of interaction, x plus n, and out of it we get y plus z plus 2n. And I can easily make a mistake right now, so please ping me if I do, because I haven't done it in like a year. So I'll just use logic and I'll remember. Okay, first of all, let's try to remember the binding energy per nucleon graph. So it's this beautiful graph, and we have iron on top. Fe. So what does this graph show? It shows that iron is the most stable element. Supposedly iron, I won't go into detail which one is, you can read it on the internet and find out it's not actually iron, but due to astrophysicists it's commonly known as iron. It's actually nickel, very close to that anyway. Okay, before I get carried away too much. So we know that we have fusion in this direction and fission, that atoms try to become iron due to fusion or fission because they're more stable. Their highest binding energy per nucleon there. So when we have this type of decay, it could be actually both fission or fusion, but most likely it's fission because we get two heavy elements. I mean, it actually could be fusion. Okay, let's not go into detail which one is which. The point is that this energy, I mean, this reaction is usually favored to get higher binding energy per nucleon. Yes, and that's why it's better for the atoms. So that's why they like. Wait, it's written that it's nuclear fission. Oh my goodness, I missed it. Okay, so it's fission. Well, it's kind of actually makes sense because we had something like, for example, uranium that decayed with the use of a neutron into some YZ and two neutrons. And yeah, thank you. It says fission. I missed it. And what else? We know that's why we know that these two particles will have higher magnitude of binding energy per nucleon because they came from here to some kind of place right there. So let's actually draw it as red. I actually used red. Let's draw it blue. Now have all colors. So we have some kind of blue region here. So Y has to have greater magnitude. if I don't mistake, because we come closer to iron. So we were here, we came here. Now total binding energy of Y and Z divided by total binding energy of X. That's a good question. What do we know? We know that on here we had more energy, more mass. So because usually due to mass defect, we get some of mass converted to energy due to famous EMC squared. So we have less mass here. And now we need to remember which one was it, which one had binding energy. Yeah, okay. You might see there and think like, how are we supposed to know? Well, I have done it a year ago, literally. And if I don't mistake, this one has higher total binding energy because some of it converts to smaller, some of that converts to energy from the mass. If anyone can please confirm, that would be great. So my guess would be, which we figured out. Figured out that Y has higher magnitude energy per nucleon, so it has to be A or C. So already, even if we don't know answer for sure, we have eliminated 50% of the results. I would think it's A because some of the energy is converted. I don't remember which one it is. Due to mass effect, it's one another. I don't remember. If anyone can think, it will be wonderful. Answering. I don't see any answers. I can just double check actually, because I have the Oxford book right here. And we need to search for mass defect. Yes, when two nucleides fission, yes. And let me find. I actually had a question about it before in the last revision, and I can check there actually. Yes, it's correct. And I just gonna copy it. And we have mass defect, and I'm not gonna go through it because I already went through it last time. Unless you want to specifically go through it, then tell me, I'll do it. So we found out that on the left hand side we have more mass, on the right hand side we have less mass. So I would say the binding energy is bigger on the right hand side. Yeah, correct me if I'm wrong, but that's what I remember, and it was horrible. Okay, let's go further in questions. How do you tell north and south end of magnetic field produced by solenoid? And let me find some good picture. Excuse me. Solenoids. And we have solenoid, and they already show the north and south. Okay, let's take this one because it don't show. Okay, now you might be scared because of the formula. Ignore it. It's not for you. It's... yeah, really. Okay, never mind. And it's gonna work. Okay, we have a solenoids, and we have. You actually have. Do you? No, pretty sure you have to know. You have current coming into the solenoid from this direction, coming out this direction. How do you figure out? First of all, let's imagine there are no magnetic field lines there. How do you figure out? Right-hand rule, and I'm actually gonna steal it again. It's, if I don't mistake, we can easily check because the answer is right there. We use the same rule as this one. Curl your hands around the solenoids and show your Yes. In the direction of the where the current comes. So it comes like this, and that's why your fingers curl like this. Magnetic field goes into this direction. And now we figure out from the same thought as a magnet. In a magnet, and yeah, I have it actually here. A beautiful magnets. Okay, let's redraw it because it's better. If I don't mistake again, because I always forget, it goes from north to south, right? North to south, yes. It was wrong. Here and here. So inside it goes through like from south to north. Here we have the exact opposite. So north is here, south is here. From north to south outside. From north to south. That's how you figure it out. So you just figure out first where the magnetic field goes and then as magnets. Try to remember which one is which. Oh boy, so many questions. Oh, Doppler effects. Oh god. Is it? Boy. That was wrong. Actually, copy image. Let's try to remember Doppler effect. A train moving at speed u relative to the ground sounds a whistle at constant frequency f as it moves towards a vertical cliff face. The sound from the whistle reaches the cliff face and is reflected back to the train. The speed of sound in stationary air is c. C, interesting. Usually c is denotes light, but okay. What whistle frequency is observed on the train after the reflection? Okay, we have the double Doppler effect. First of all, we have the Doppler effect coming because we actually send it. And then we have some kind of frequency that's reflected. But we are moving observer and we receive different one. And now the question is which one it is, and I can say there's probably A or D, and which one it is, it depends on actually the formula. Now we actually have to think. Here's my data booklet. And by the way, it's HL, I was wondering. Okay, we have the moving source and moving observer. First, we have a moving source. So since source is moving, it tries to get the field of the sound waves closer together, so frequency is smaller. And I got some kind of pink. Let's double check. Is in live video? Yes, just yes. Check the import files and links. It's stream. Yo. Okay, continue. We have the frequency decreased because we have them together. So yeah, if I don't mistake, let's double check because how we can figure it out. So speed equals frequency times wavelength. Wavelength is shorter. Oh, what the hell was I saying? Frequency is higher because we have shorter wavelength because they're all packed together. That's right. Now it makes sense. I felt like I was saying wrong. Okay, let's go through it together. Why is it higher frequency? Because we have the waves closer together, more compact, so higher frequency. Other way to think of it, we have formula right here. So wavelength decreases because they are more compact together, so it goes down. Since speed is the same, frequency has to go up. Now it makes perfect sense. Okay, sorry. So received frequency from the data booklet, and we have moving source, right? Equals f. Let's use the speed. S plus minus u. So we have higher frequency. So we have to multiply by this number that should be bigger. So to get this number bigger, this should get smaller. So we have to use a negative sign. And I hope it makes sense. Let's think of it. So we get more negative number. This number gets bigger than 1. Frequency increases. Yes, should be like that. So let's go through it together. Once again. So our observed frequency should be higher from figuring out this part. This frequency stays the same, this stays the same, this stays the same, and this stays the same. So it should be either positive or negative. Which one is it? Since this term stays the same, and this one changes, Now this one has to increase. To increase the term in the fraction, we can decrease denominator. How do we decrease it? We use negative sign here. That's all. That's why we have negative. So our observed is this one. Now we reach cliff face, and now we get the reflection. So train now we are train and we are moving, we are observer. And since it's moving observer, we use other formula. And let's use other color. And C plus U divided by C. All from data booklet. I literally just write from data booklets. Okay. So since we're moving towards the waves, they come to us much closer, so higher frequency. So same logic. Higher frequency. These terms stay the same. So wait, I forgot the minus, right? Minus, different color, but okay. So this has to increase. In a fraction, well, we're not dividing, we are multiplying. So we have to use plus to increase our frequency. Excuse me. So which one F is it here? It's this one. Or this one, to be more precise. Because I mean the same thing. Because it's the one that's reflected against the wall. So we put in this term, and we cancel out this, and we get that observed is equal to F C plus U divided by C minus U, and should be A. It looks a bit slow because yeah, you have 90 seconds, but because I will write out and try to find it. Usually you should try to get lots of time on first questions and then reuse it on later questions such as this one. Yeah, if you actually write which answer it is, it will be much easier for me to check that I'm actually doing the right work. Otherwise, it will look pretty stupid after a while. Yes. Can you please explain tables in 10.2? Let me think. Because I've already done the explanation and it took me like 10 minutes. It will be the best if you rewatch it. I'll actually find the video for you. I'll be so generous to do that. And I'll even find the moment where it is. Dun, dun, dun. Okay, you cannot see anything yet. And this one, internal voice. Actually, I need voice. That's why you equate half mv squared, so kinetic energy. Hello, old me. Is in this part. I'll often ask in IB, velocity. So it results in higher orbit, elliptical orbit usually, and yeah, somewhere here that they might give to you. Okay, now we come to questions about topic 9. Okay, topic 9, it was topic 10, so somewhere like here maybe. Is that the two sources are far enough, like their top center, or does accelerate fast on string by mass? So that's kind of the key of it. From knowing potential, we can easily apply it to any mass we know. We don't have. Yeah, somewhere here. Yes. Okay, we'll figure it out because it's plus minus 2 minutes probably. Okay, where do I share? Starting from this point. I'll share it in. Okay, I'll share it in discussion. Table 10.2. And I'll share it on the stream because why not? So table 10.2. Yeah, I think you should watch it. I'll give a quick recap though, because I'm really generous today. Maybe I'm always generous, I don't know. Okay, you're not supposed to look at this, so let's just hide it really quickly. Boom. Yes, perfect. Let me find the data booklets. Dun, 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 dun. and I can show this. If it works. And I'm gonna use the annotated one because I don't have the usual one downloaded. I have this one downloaded. And we get to this one. So basically similarity is exactly the same for both gravitational and electrical one. The difference is that in electrical one you can get both attractive and repulsive forces. Yes, and in gravitational it's always attractive. That's basically it. So potential. First we have potential, and I'll go through the gravitational because the idea is similar for electrical one. It just can be negative sign there instead of negative or positive sign instead of charge. So easily enough. So what does potential show? Well, the easiest way to explain potential is probably the work we need to do to move between 2 points per unit mass or per unit charge. So it's basically a property of a planet or a property of a charge. I mean, it's not really a property, but I call it a property. It's easier to understand in your head. Excuse me. So basically, work you need to do to move from one point to another. Remember that the fields, electric fields and magnetic, electric and gravitational fields are conservative. So it means no matter what kind of way we take, we spend the same amount of energy. I mean, we do spend energy coming, for example, from orbit to Earth. If you want to move to another orbit, we move from Earth to another orbit. It will be the same energy if we just move from one orbit to another orbit, because we gain energy when going down to Earth, but then we lose it again when we come to another orbit. Of course, it's simplification. It's not accounting the lose of energy or when we travel on a rocket, say, or something like that. Not counting the atmosphere, not counting friction. It's just it is a kind of simplification in its case. Yes, so potential basically per unit mass or per unit charge, how much energy you need to travel between 2 points. Field strength, on the other hand, I think it's pretty easy actually to understand when I say that it's basically acceleration. It's basically what acceleration we feel at this point. And it's just very cool conversion between potential and field strength. You just divide by another delta R, delta V divided by delta R. Basically, average acceleration that we experience in this part of the planet or orbit or where we're located. It's very easy actually if you understand that. Don't write that it's actually acceleration, okay? You might actually have to write that it's meters per second squared, but it's field strength. Potential energy, I think from mechanics view, all actually remember it's really good. It's energy that you have at specific points. So how much energy, well, technical term will be how much energy you gain or need to move from where you are located. So say from Earth to infinity, so where the gravitational force on you from Earth is 0. And we come to force. Well, force I think is pretty kind of obvious. It's attraction or repulsion. So I'm attracted to Earth, that's force. That's pretty much it. Oh boy. And can you go over how to find the mass defect? Okay, we actually came back to it. Yeah, I'm kind of slow with the questions, so I hope that's okay. It takes like half an hour to explain, but I try to explain it like properly to make sense. And I think I need to fix something. 1 second. Where was it? Voice, right? Let's make it like somewhere here. I should make it better. I have no idea if you hear it as stuttering, but maybe it's gonna be better. I forgot to do that. Mass defect, right? And I can just open this one. And we copy, for example. And I have all the numbers because that's cool. Okay, so we're not doing A because that's boring. We're doing B, that's more fun. We have, oops, it's drawing. We have helium, so helium 2 plus and 2 neutrons. And a neutron. But they are the product, right? Then we move this one. Let's say move. Okay. That's a bad idea. Let's change it. Let's read it properly. We have 2 hydrogen isotopes, so we have plus and plus, plus, and then we have 1 neutron. Wait, I did something, but yeah, like this. Now it makes sense. So we have 2 neutrons proton plus neutron and proton, and we get 2 protons, proton, 2 neutrons, neutron, 2 protons. Should use different color, but okay. Plus, no, energy. And so we have this reaction, and we are told that these masses for different elements, different isotopes. We need to find this energy. So like, what's this energy? Well, we're given the masses of this, this, and this. So what do we do? If you actually don't know what to do, just simply try to calculate. Just think logically. What would you think would be added? Mass defect. So you need to find the difference in mass. So we know the mass of this one and mass of this one. Easy. Left hand side. Yeah, this one plus this one, and that's what you get. Now, right hand side we have helium and then we have neutron, but we don't have neutron. And then if we go to data booklets, page whatever, we find out neutron rest mass, and we have it in U, unified mass. Okay, let's think what's actually U, and it's this one. What's U? It's basically just a unit, just to make our calculations easier. So instead of writing that neutron is 1.637 times 10 to the negative 27, it's much easier to just write that it's U, so just unified mass. And the conversion is also in the data booklet. Is it? Yeah, this one. So 1 U is 1.661 times 10 to the negative 27 kilograms. So 1 proton and 1 neutron is about 1 U. Not exactly. And this not exactly is very important here, because if you round off, you lose basically loss of energy and marks, obviously. So we find left hand side from the table. The table will be given unless you need to find neutron or proton, which is given there. Now right hand side is helium and the neutron. So easy enough. Left hand side, right hand side. Find difference in U. Okay. What's U? We know that 1 U is this amount of kilograms. So we multiply them out to convert this into kilograms. How do we know that we need to multiply? Okay, think of it. If I had 1 U, what do I need to do to get a 1.661 times 10 negative 27? I need to multiply. If I divide, I get a huge number. 1 U, 1 proton doesn't weigh 10 to the 27 kilograms. That's like 1,000 more than Earth, if I don't mistake. So we got kilograms, that's SI units, and we love SI units, and we have EMC squared. We know mass, that's speed of light, multiply, get the final answer. That's all. It's not that hard. So what are the steps? Find left hand side, find right hand side mass. Find the difference. It should be positive. Just remember, if you get it negative, just scribble it away and write positive one, because examiners might take away marks if it's negative. And if you just write over it, they cannot do anything. Convert to SI units, EMC squared, get the answer. Isn't fusion two light elements? Yes, it is. Yeah, okay, I read it was long. When will the session end, by the way? Yeah, okay, 3 hours. I don't have much time, maybe in 2 hours. I have my own exam, so I hope you can forgive that. I go study on my own. Yeah, this one has been posted a lot of times. I've seen it myself. I guess I can just. What did you? Okay, I'll go through it because people are seem to be a bit confused by it. Because this question is a bit that type of question where mathematicians just are like, what the hell, why do you do that? And physicists are like, how else would you do it? Okay, so a thin-walled cylinder of weight W, open at the both ends, rests on a flat surface. The cylinder has a height L, an average radius R, and a thickness X, where R is much greater than X. And that's key. That's pretty much the key. So in the math terms, you would write R is double, so greater than 2 times X. What is the pressure exerted by the cylinder walls on the flat surface? Okay, so we know that pressure is force divided by area. So what's force? Force is weight, because that's our weight. Yeah, should be pretty straightforward. Now we need to figure out the hardest one, the area, and we can see from all the results that only area is different. So it's kind of obvious which one is hardest to figure out. So we need to figure out the area. How do we figure out the area of a cylinder that's open? Well, let's figure out first the area of the whole thing. So we have whole thing. So let's figure out first the area of this one. So that's PR squared, as we know. And yeah, of course, that's PR squared. And then we need to figure out the inner circle, so the inner one. And that's PR minus X squared. And if I don't mistake, that's 8, and you should just subtract this one minus this one, and you get the area. And that's gonna look horrible, but P times R squared minus this one. So let's open the brackets, minus X squared. So these terms go away. Now we are left with 2xr minus x squared. Let's check the answers. Okay, 2pxr, yeah, but there is x squared here and the r squared doesn't really sum up. That's the key. You need to remember r is much greater than x. What does it mean? It means that we can just forget about this term. I know that probably sounds like a shock for some of you, especially mathematicians. It took me some time for me to get used to it as well, but why can we get rid of this in this case? First of all, hint where r is much greater. Second, when we have extremely small number compared to r, if we square it, it gets even more smaller. So we have 0.1 squared, it gets 0.0, it's equal actually. So it gets even smaller. And now some people might ask why we don't cancel x here. Well, because we multiply by r. We have small number multiplied by big number. Well, it makes it an average number, let's say. It makes it a kind of number, okay number. That's why we cannot get rid of this one. X here squared is on its own here. So that's why we can actually just remove it. And we get 2xpr, which is 2xpr. We get a. So basically we can get rid of it only because it says that it's much greater and it's on its own, and also it's squared. It's even bigger like hints. Whew, it's a fun one. Resistivity force which increases with speed, therefore engine power must increase exponentially. What? Is that a question? Okay. If it's conceptual question, I actually... Engine power. I'm not that good with cars, actually. I cannot comment on that, honestly. Question 4, please. Oh no. Yes. No. I don't like waves, to be frankly honest. And I'm not that good at them. So if I do make a mistake, please correct me. Because I can make a mistake, and that was a bad idea actually. I can just reuse this. Okay. Come on. And we have this question. That's okay quality. So diagram shows wavefronts of a wave entering a medium in which the wave speed decreases. Which diagram is correct? If I remember correctly, I already did the question before and I couldn't figure out which one it is. I remember for sure that it's not COD, because I think it should be at this angle. And I got some kind of... The agent question was removed by the user. Okay, thank you. Yes. Why is it not COD? If I remember correctly, it simply cannot go this direction. It goes this direction. Now which one is it? Okay, we have C equals F times wavelength. So speed is equal frequency times wavelength. Speed is constant, so frequency of 1 times wavelength of 1 is equal to... Wait, I said it wrong. Never mind. Frequency is different. No, speed is different, frequency the same. That's correct. And I got some kind of pink. Let's double check. I'll get to it. Okay, frequency the same, so we divide one by another and get frequency. So frequency are the same, so we can equate them together. So frequency here and here are the same. Or are they actually? Oh, they should be the same, right? So speed of 1 divided by wavelength of 1 is equal to speed of 2 divided by wavelength of 2. So wavelength of 2 increases, and to make it why is this increase? Well, because it increases here. Is it? Wait, this one decreases. Right, I forgot. The wave speed decreases, so this one decreases. So to make this one equal, this one should also decrease. Right, is this one. Why did I choose this one? Okay. Yeah, should be. Wavelength should decrease to account for decreased speed, since frequency is the same. That makes sense now. Because you can see, like, I myself don't make like immediately get the answer. I have to think. Obviously, I make mistakes, so you have to double check. Obviously, on the exam, you see it there, like, doesn't make sense. Come back to it later. Double check your work. Oh wait, it does. Why would I don't know, frequency would be different, like same or? Your mistake is B, and someone said it was B. Yes, wavelength decrease, and so does the angle to the normal, right? Yes, because it's different medium, because the refraction index is different, and honestly that's all I can remember. I don't remember. Why is it? Don't ask. No, it's A. Yeah, exactly. Damn it. I think I said that I did that question and that I got it wrong last time. I guess I'm right, that I was wrong. Is it past papers? Is it from past papers? If it's past papers, I can just try to find it in question bank. I'm pretty sure I saw it in past papers though. Let me double check because I have it right here. And I'm not gonna show it because I have my name there and stuff. And the diagram shows. Its wave speed decreases. The speed of wave in medium X is greater than medium Y. Yeah, I think I found it actually. And here we go. Okay, let's actually make them so that you can see both questions. Let's not show D because it's basically okay, the answers are almost the same, just C and D are inverted. Okay, so speed of X in X is greater than speed of medium in Y. Entering a medium which wavelength decreases, so yeah, also decreasing. And the answer is B. The same as me. And then it means the book is wrong and, well, it's question bank, so I think it should be more correct. Okay. Yeah, please use discussion like, yeah, we discuss. Where I get the question from? Let me find, I think it was 14. It was May 2014 SL time zone when I even publish. Here and I'll publish it on the stream because this one. Let's see. Okay, more questions. Where was it? Okay, I've answered this one, I've answered this one. Wait, where did that question go? No, wait, it was this question. Right. Should be B, yes. Please don't discuss, come on. I'm confused to how to derive the question. All that pressure. Wait, did I already do it, or is it still follow up to this, to the work I did? Fluffy Kings, can you please say if you've already understood the my derivation, or did you figure it out from my derivation now? If I don't see any answer, I'll just assume. Please ping me when you answer, because I have no idea where you answer. And that should be ignored. Boop, 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 boop. Okay, I don't see any answer from Fluffy King, so I'll just ignore it because I just did, because I think I did after he asked. How do you work Rayleigh criterion and resolvent equation? Yeah, okay, I was talking about right now. Yes, okay, it was correct. Of course, it's always these hard questions. That's HL, by the way, those wondering. Where was it? This one. Resolution, yeah, this one. So good that I did presentation before, I can just reuse it so easily. Isn't it great? And come on. Oh yeah, this one. So again, as you can see, we have the, forget this one. I mean, just want to remove it just in case. We have this Rayleigh resolution. So we have theta. Theta is angle to the first, technically, minima, where maxima is at minima. So yeah, it's a bit confusing. B is, if I don't mistake, the diameter of the resolution. Actually, I can just double check right now. I have the annotated booklet right here. So that I don't like slit width, yeah, basically. Well, lambda is always the wavelength. So first, minimum for diffraction is circle aperture. Yes. So what does it actually mean? So we have two tops, and we want to resolve them so they're not something like this one, because now it looks like we have one object that's emitting, for example, it can be like one star. That's a wonderful star. And we only see it when we try to resolve, for example, with a camera. It's small. It's like a camera. So if we increase B, we decrease theta. So we get bigger camera, like enormous camera. We decrease theta. And what does it do? And let me double check in my cheat paper. If I don't mistake. Okay, let me give me a second because I haven't done this in a long time. Decreasing angle. Well, it's angle to the first. Where's my mouse? To the. Okay, it's here. And I lost again because it's. Wait, what? My mouse is stuck on. Oh, okay, it's back. Is to the first minima, right? Is it first minima? First minimum, yes. So if the first minima appears on the first maxima of another object, so we have two stars actually here, then we cannot resolve them. Or like we can just barely resolve them because we can see them very close together. If they're even closer, so the angle is smaller, right? Oh, that doesn't make actually any sense. Okay, I'm gonna lie right now. That's why I want to lie right now. Let me double check in Oxford book. And that's not Oxford book. That's actually Oxford book. And I'm not sure if I'm allowed to show it on the stream, so let's not show it in the stream. Now I need to remember how that guy is written. Yes. Here it is. And I don't explain properly. And let's do some googling. Oh boy. I'm really sorry because it takes so long, because I didn't expect this question, because it was literally just out of nowhere. Let me just say this thing. I don't remember. Double check. That's what I remember. Is I'll even give you the definition. The images will be just resolved when the diffraction pattern from one of the point sources has its central maximum at the same position as the first minimum of the diffraction pattern of the other point source. So again, it's just resolved when they're just on each other. I don't remember. Angle is angle to this one. So theoretically, bigger angle means minima is here and they're not resolved. Yeah, I think that makes sense. So smaller angle is better, so bigger camera is better. That makes perfect sense. Okay, I figured it out. I'm sorry. But double check because I don't want to lie and then fail your exam, but that's what's if I don't mistake. So smaller angle. Here we have very small angle to first minima. Those they resolve perfectly. Here the angle is bigger, but it's still small enough to be just resolved. This 1.22 shows which angle conversion, like constant, which shows just resolving. I don't remember it, what derivation we don't ask. Here the angle is bigger, so they are not resolved. So we have a very small camera here. So if we increase the aperture size of the camera, angle decreases and we get resolution. So this one is this one, and this one is this one. So we either see as 1 star here or 2 stars as from here. Okay. Hope I didn't make it worse for anyone. Okay, I found this question. It says answer D, but isn't B technically also true? A lift elevator is operated by an electric motor. It moves between the 10th floor and the 2nd floor at a constant speed. One main engine transformation during this journey is electrical energy becomes thermal energy, electrical energy becomes kinetic energy. Well, the question is its main energy transformation. If I think of it correctly, then electric motor then probably loses the most amount of energy to thermal energy due to friction, and those they expect it to be D. It's actually a bit strange question because I wouldn't expect AB asked to something like main energy, because are you really supposed to know it? And I was pinged. If you're asking the new question, please don't ping me because I'm gonna get to you. Takes time, but I'll get to you. Okay. And okay, I'll do one more question. Then we're gonna have like short 5 minutes break. I just need to drink some water and stuff. Okay, can you help? The answer is A. A particle. Oh no, a simple harmonic motion. Let me get then the. Where is it? It's here. Particle. Hello, particle. Go back. Here we go. Good enough. A particle P executes simple harmonic motion about its equilibrium position. Why? Okay. The amplitude of the motion is xy. At which of the positions shown in the diagram is the acceleration of P equals to 0 and the kinetic energy of P equals to 0. Okay, so if I understand correctly, then particle moves like this. Okay, understandable. Excuse me. So we started. So let's say this is displacement graph, because that's probably the easiest way. Figure out from displacement, velocity, and acceleration graphs. One's derivative of another. From there you can figure out all the parts. So we have this one. This is displacement. Add sine graph. So what's the derivative of sine? It's cos. What's the derivative of cos? It's negative sine. I mean, you can probably figure out thinking like trying to remember it, but for me, I think in math sense rather than trying to remember. That's easier way to remember which one's which. SVA. So this is equilibrium point. So about its equilibrium position y. So this is point y. This is y, and this is y. So one of the say bottom is x position. So we want to find the acceleration. So y acceleration is maximum. At the bottom or top, so it's x. And kinetic energy, what's kinetic energy? It's half mv squared. So it depends on v. Where is v maximum? Well, what?
Isn't it asking for where those two are zero?
Good catch. Thank you very much. That's a very good catch. It's a bit hard to talk and think at the same time. Thank you very much.
Thank you very much.
Yeah, so it should be A, right?
Okay, let's double check. So acceleration is 0. So at y point, a kinetic energy is maximum at x point, because velocity is max there. Pretty sure is A. Yeah, answer is A. Yes, it is correct. Yeah, that's all. Okay, I'm gonna have a short break, like 5 minutes or until like 35. Yeah, you can still ask questions. I'll try to get them as soon as I'm back. Break. Okay. Think microphone is working, right? Whew. Okay, break is over. Let's continue. Yes, I've read through the questions. So if you do figure out some question, please delete the question from the questions so that I don't repeat it if you already know everything. So there's no point. For example, this one. If you figure out that it's old syllabus, please delete the so that I don't spend time on reading the same things. Trying to figure out where it's coming from, then it's not relevant. Okay, so this one, yeah, I think you still didn't figure out where it's coming from, so let's do it. If you still ask, I can answer. No problem. Okay, the cable consists of 32 copper wires, each of length 30. Let me double check. I actually. Okay. Is stream up? Is stream up? Yes, it's up. Okay, sorry, I just need to double check. Okay, the cable consists of 32 copper wires, each of length 35 kilometers. Each wire has a resistance of 64 ohms. The resistivity is given. Calculate the radius and show that power loss is that. And I probably got. He figured it out. Can someone tell him to skip it? Okay, skip it. It's understandable. If does anyone want me to go through these questions? Pick up now. Or write it. If I don't say anything within 5 seconds, I'll just skip it. I don't see anything. Okay, then I skip it. Never mind. Yeah, please delete questions that you figured out. I'm gonna spend time on them, so yeah. Okay. Oh, I get why in kinetic energy at max displacement, but why it notes acceleration is 0 from the graphs. Okay, why is it 0 actually? Okay, conceptually. Okay, let's imagine it's non-zero. So let's imagine that we have some kind of a string that does motion back and forth, simple harmonic motion, and now it's equilibrium position, y, so it's x here. Okay, let's imagine the acceleration is not 0 here. What does it mean? It means that velocity increases, but our velocity is already maximum here. That makes sense. Yep, that's all. It's conceivable. What's conceivability? Why is it d what? Let's try to read. Is it this question? Okay. And let me try to make it. Can I copy? Copy. Perfect. And that was one wonderful idea. And try to reduce. Dun, 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 dun. Some nice fingers here. Great pen. The graph shows a variation with time of the displacement of particle in a medium when the wave intensity E travels through the medium. The intensity of the wave is halved. Which graph now represents the variation of displacement with time? The scale of the graphs is the same. Okay, so we have change in intensity. What does change in intensity do? Let's check data booklets. And we have this formula. And it does right, because it's awesome. And intensity is proportional to the amplitude squared. So if we halve the intensity, then we halve the amplitude squared. So what does happen to the normal amplitude? Square root of 2. And okay, so it's not C for sure, because we need to decrease amplitude by square root of 2. This one I think is halved, and I think this one is also halved. Should be D. That's all. I'm pretty sure the answer was D. Why is it d? Because we have acceleration that's square root of divided by square root of 2. It's not halved because we halve the this acceleration amplitude. We halve the amplitude squared, so usual amplitude is divided by square root of 2. How does constant speed mean its thermal energy? What? Okay, I got some ping. Let's double check. Welcome. Yes. And Discord, please don't say that. Don't have new unreads. How does constant speed mean its thermal energy? I don't really understand what this question is trying to ask. Like, what does happen? What does constant speed mean on, like, how does it? So what happens with thermal energy if the speed is constant? Well, depends what speed, because thermal energy is about kinetic energy of the molecules. If it's total energy of the block, say, then individual molecules don't increase in energy with increased speed of the block. Unless I get some. Sorry, that was about elevator question. Okay, elevator question. Because motors are not perfect, they don't transfer all electrical energy to kinetic energy. So when I have an elevator, so when I have elevator moving up and down, people there, the motor it's on the top, right? That's working. It moves people up and down, right? But the electric energy that I get in here, so E, not all of it goes to move it up and down. Some of it goes into it's wasted. It's because entropy increases, and then you can go into thermodynamics, and I want to say something wrong, so just let's say that it's not perfect. There's friction in the motor, different parts moving, the friction on the cables there, and all the kind of stuff. Well, yeah, I didn't like the question because it kind of like implies that there is more thermal energy than kinetic energy. Which one is more? It's a question on the motor, like what's the efficiency of the motor. I would say it's probably around 20%, so 80% wasted, so most of it is thermal energy rather than kinetic energy. I have no idea. Okay, that's different questions. Well, okay. Because constant velocity, there is no net force increase kinetic energy, all energy goes to thermal. I mean, his explanation was wrong. Okay, maybe. That's actually a good point. But let me think a second. That makes actually sense. Well, from other perspective, we try to slow down elevator as well, but yeah, that's not kinetic energy. Because otherwise elevator would fall down if we didn't slow it down. So it works against gravity to have constant acceleration when moving down. Please say if I'm very wrong. Please ping me at least and say that I'm wrong. I can say something wrong because first of all I talk, second of all I think at the same time, so it's very easy to make a mistake, stupid mistake especially. Charged particle enters a uniform magnetic field at 90 degrees to the magnetic field lines in a Bainbridge mass spectrometer. What happens to the momentum of the particle and the kinetic energy of the particle as a charged particle moves in the magnetic field? It's a good question, IB. I think you can figure out on yourself though. Why ask us pure students, right? So we have some kind of particle entering the magnetic field at right angles. So what happens to the momentum and the kinetic energy? As you remember, the particle moves something like this, so it kind of changes its direction. Kinetic energy is a scalar, so it's it was bad. It's half mv squared. Velocity doesn't change because only changes direction. I mean, velocity changes, speed doesn't change, which is the one used here. Mass doesn't change, so kinetic energy unchanged. Momentum is changed, however. I mean, depends where it ends, but probably since if it's mass spectrometer, it's usually something like this. It enters like here and falls down here. It doesn't make a full circle. So the velocity is different because the vector, like where it's moving, is different. That's why momentum should be different. So I would say it's C, because momentum is a vector, kinetic energy is scalar, kinetic energy doesn't change because speed doesn't change, velocity changes, so momentum changes. Oh boy, it was, you haven't seen anything. It was personal message. Velocity is a vector, surely both should change. Well, kinetic energy is a scalar, so nope. Okay, explained. This one. Dun, dun, dun. Please ask more electricity questions. I have examined them in like 2 weeks, so I have to know them. Okay, you can ask any questions. I was just joking. A 3 coulomb charge and a negative 4 coulomb charge at distance x apart. P is at distance x from the 3 coulomb charge on a straight line, joining the charges. What is the magnitude of the electric field? As we know from the data booklets, and where is it? Electric field is, force divided by the charge. So test charge. So if force is K Q1 Q2 over R squared, then we divide by Q, so either of them, that basically the one that's at point P disappears. Now, some of you might say, what the hell is this epsilon? I've never learned that, I've never seen this in my life. Let's try to open our data booklets. And that's not data booklets. Oh, it's here. Never mind. And we go to the SL and we find this one page formula. What is it? It's our dear epsilon. K is related to epsilon, and then we have magical for pi, and okay, it's story for another day why pi there and why 4. Well, that's quite interesting story actually. So we have K, and we can substitute for pi epsilon 0. Epsilon 0, it's permittivity of free space. You don't really need probably to understand it too much unless you actually do HL and you remember capacitors. Then there you need to know about dielectric, if that's the word, if I remember correctly. And epsilon is different there, becomes bigger, changes the capacitance, and you need to remember that, and you need to know that. Okay, back to the SL. So 1 over 4 pi epsilon. So that's the one that we need to use. 1 over 4 pi epsilon 0. And since we're gonna use the field, so we do Q over R squared. Due to superposition principle, we can just sum up 2 fields and get the actual field at P. So first one is 3. So let's say E1. E1 is, for example, from positive 1. So Q is 3 or 4 pi epsilon 0 x squared, because distance is x. And that's all. Field from second one, so from negative 1, is negative 4, because charge is negative 4. 4 pi epsilon. But the distance is 2x. But remember, it's r squared, so 2x squared, so 4x squared. And we can cancel out force. Now we just add these two terms together, And very beautifully, they have the same denominator. We have 3 minus 1 over 4 pi epsilon 0 x squared, which becomes 2. And we can solve this one, becomes 2. So we get 1 over 2 pi epsilon 0 x squared, and that's b. If you make mistake calculation, then that's all. So just really good to remember in the data booklet that you have actually something that you usually don't use because k is given value, but it's actually equal to 1 over 4 pi epsilon 0. And remember the superposition principle, like forces, you can add them up if they're in the same direction, so you don't care that they're like at right angles, say. Here they're same direction, just opposites, and parallel to each other, so different directions, opposite directions, but parallel to each other. So you can just sum them up like normally. Okay, yeah, B, yeah, that's what I thought. Okay, we finally came to the end of the questions for now. I'm sure more will come. Yeah, I'll say I'll end about 1 hour. A bit more, a bit less, we'll see. Still remember last year I also had like physics exam. It's my last exam actually. Oh boy, that was not easy. The grade boundaries were low, so it was okay at the end. A satellite X of mass m orbits the Earth with period t. What would be the orbital period of satellite Y of mass 2m occupying the same orbit x? There are two ways to think of it. One mathematical, another one is conceptual. I will go through probably both. And yeah, okay, we probably don't have it in the data booklet, but average, let's say, or like one of the velocities of orbit is gm over r. So since we don't care about this mass, the velocity is the same. Since the linear velocity is the same from the, by the way, is it actually HLS? I have no idea. If that's HL equation, that's mathematical approach. So since velocity is the same, I mean, you don't have to actually, it's not necessarily this velocity, but you can get the idea. Then period t will be related to the same velocity, so it doesn't care about mass. Actually, you can use just circle motion. What the hell am I thinking? Using SL part, we have this one. So period is related to velocity, radius, and since velocity is the same, yeah, it does depend on the mass, and depends on radius, which is the same, period is the same. Second way to think conceptually. Okay, let's imagine we have Earth, so green Earth, and we have some satellites. But let's imagine it's not satellite, it's International Space Station, because it's easier to think. So we have International Space Station, and we have some humans inside, obviously. Let's imagine that human is not holding the station itself. The mass is completely different, but they're obviously in the same orbit. Well, they're moving the same orbit, so yeah. Imagine that the time period will be different. It means that human would move faster or slower than the satellite inside, so satellite would hit him with, like, I don't know, double the velocity. And it doesn't really happen, you don't see it in the news. So that's obviously same time. Answer is B, yes. This one, okay. You got out D anyway. Oh boy. That seems a bit scary. When electromagnetic radiation falls on a photocell, electron of mass m are emitted, provided the frequency of radiation is greater than f0. What is the maximum speed of the electron when radiation frequency f falls on the photocell? And that's, I actually don't know if it's HL or SL. It really looks like the work function questions. How's it called? Oh my goodness, I remember it. You HLs know what I mean. Where there's light on the metal and then that gives off electrons. Yo. Kinetic energy. Actually, I have to think about this one, right? Is it not actually that? What's it called? Let me double check. Photoelectric effect. That one. It looks like that one. Because I think if it's double half mv squared. Yeah, I think it's. Where's my mouse again? Yeah, here. Pretty sure it's HL. So we know that energy max is HF minus work function. However, we know that energy is also from the data book as well. And I got someone mentions in physics. Okay, sorry, too busy. It's a bit far. From here, kinetic energy of free electron photoelectric effect. This one is energy of photon. It's HF, so we can just substitute the work function with HF, but 0 because it's radiation greater than 0. So we can write it as HF minus F0. We know that kinetic energy is half mv squared. So solve for V. 2HF minus F0 divided by V squared. So square root of this. B looks correct, yes, that's all. Let's double check that. Okay, thank you, Edge Communist Charizard. Yes. In some past papers, they mention artificial induced transmutation. Can you briefly go over this term? Yeah, it was a bit awkward one time on in physics channel they asked, and I thought transmutation, that sounds like biology. Transmutation, artificial transmutation, is when we have some kind of particles, like gold, and we heat it, bombard it with some protons or nucleus, helium or something, and try to get some kind of other particles, say. So we want to get it more protons or neutrons to get to become something else, like uranium. So I'll get a great picture from Wikipedia. Artificial transmutation, if I spell correctly. Nuclear transmutation, yes. Yes, conversion of one chemical element to another, and if I don't have any good picture, really. Good enough. I answer for them. Yeah. Okay, I'll just do it again with the picture, and it will be also on the stream, but thank you. So basically we have some kind of nucleus, so say aluminium, we bombard it with helium to get either phosphorus, and we get something like left, maybe, say neutron or electron. And basically we change our initial particle in something else. So theoretically we can take lots of helium and get gold after lots of time. It requires lots of energy and is basically fusion in itself. Kind of. Not really, because you can get even bigger particles than past iron. Fusion can only get to iron. Okay. Okay. Did I miss a question? Okay, let's try to answer this question. You can only have artificial transmutation occurring for anything to the left of iron 56 on the binding energy curve, correct? I would not say that because it's not necessarily fusion. I can double check to not lie. But I would say no because maybe you want to get like a, yeah, here like in the equation on the stream you can see it. We have uranium and we get plutonium. Yeah, this one is from the data booklet. Just a data Wikipedia. And you cannot see anything. You can see like this. So we have gold. We add neutron. That becomes radioactive. From there we get mercury that we bombard with neutrons until we get some kind of thorium, and then we get what is it even? Lead. It's called lead. Yes, thallium to lead. And if we check binding energy per nucleon curve, is there anything that's really detailed? No, it's not really detailed. Ah, boy. Details. Yeah, this was a good picture. Okay, as we can see, gold is here and lead is here. It's actually hard to see whether one is high or not. Let's actually get a table. It will be most safe. I know I take a bit a long time, but I'm interested myself actually. I don't wanna. Add atomic mass. I found lead one, but I don't see gold yet. Gold binding energy per nucleon. And I know you cannot see what I Google, and it's, oh boy. So gold is 7.915 and lead is 7.88. So yeah, lead is lower. Yes, it's lower than gold. And technically that's not what we want. In artificial one we can just get anything. I can get from iron to uranium theoretically. It just takes lots of time. Okay. Again, if someone answers you in the discussion question, you just delete the question so that I don't go over it again. Yes. Two electrodes separated by distance d in a vacuum are maintained at a constant potential difference. An electron exchange from one electrode to another gains kinetic energy E kinetic. The distance between the electrodes is now changed to 130. What is the gaining kinetic energy? Oh boy. That's a good question. That's a good question. Let me check data booklets.
Sorry, but doesn't it say that an electron accelerated from one electrode to another gains a K of EK in the question?
Did I say something else? Yeah, I meant just some kind of energy. Just trying to figure out what it gains if it's 1/3 distance seconds. Okay, I got a ping. Are you on a gap year? No, I am not. I'm studying in the university right now. It's not really relevant. There was a formula that I don't remember. It was pinned messages. And that's how I horribly... Yes. No, that's potential difference, right? Potential difference between two electrodes is voltage divided by distance. If they are the same potential difference, that's right. So if we change D to 1/3, then we change voltage to 1/3. I don't know how it helps, but okay. That's actually a good question. Oh boy. Honestly, I have no clue. Let's check the pings. Hopefully they can save me here.
Yeah, it's because they're held at a constant potential, so the kinetic energy required is constant, so it's just EK.
Yeah, I'm thinking the same thing. Just wanna say it wrong. Since PD the same, gaining kinetic energy the same. Probably is correct, actually. Thank you, yes. Thank you. It's probably yes. That's the answer for that one is okay. Because sometimes I actually mistook these questions, and sometimes it's asking about potential, and that's potential is different. Wait, yes, I said it wrong. Potential difference is the same. Okay, let's get from before I say something wrong. Since the potential is the same, the energy, kinetic energy gain is the same. Yeah. Yeah, because it's probably the electric field might be stronger, but the distance is shorter and they cancel each other out equally. Probably is that's the case. Potential energy is Q times V. Yeah, okay. If potential is the same. Wait, I wrote it wrong already, right? V equals Q. Yes, and then yeah, potential is the same, charge is the same, work is the same. Yes, correct. Thank you. So I can easily make mistake. Please correct me if I say something wrong. Let's continue with the questions. And wait. It's very hard when it's deleted, like, to get back connection. Yeah, got okay. Never mind. I don't see more questions. Okay, here it's just 12 hours until your exam. Oh boy. Okay, black body emits radiation with its greatest intensity at a wavelength of I max. The surface temperature of the black body doubles without any other changes occurring. What is the wavelength at which the greatest intensity of radiation is emitted? Okay. And we got some other pink. No, what did I do to afford before my physics exam? That's a good question. If I don't mistake, I had psychology exam the same day. It was Monday, right? I think I had psychology paper 2, physics paper 1 and 2, and I probably studied psychology because it was much more subject than me. And I probably later gave up and just went to sleep. Sometimes you just need to stop studying. You won't learn much new, you'll just stress yourself out. Well, I got extremely okay. Let's get back for from the physics for a second. And psychology does require quite a lot of studying because you need to remember so many studies, and I didn't really focus for it throughout the year. But because I got super lucky with the questions, extremely lucky. Yeah, I got a 6 event, so it was. I totally didn't deserve it. So those who I don't know if you already took psychology or not, good luck. Hopefully you'll get as lucky as me, but it's hard to predict. Okay, Black Body. And we have this one. So we need to correlate intensity is and max wavelength. So wavelength is 2.9 times 10 to the negative thirds over the temperature. And power equals to emissivity times constant times area times temperature to the fourth. What's intensity? Intensity is divided by area, so we remove this factor. So it's intensity. No. Wow, it's even simpler. What is the wavelength at which the greatest intensity of radiation is emitted? When the surface temperature doubles. So this one is doubled. Wavelength is divided by 2. Isn't it just B? Double the temperature. So wavelength decreases. Yeah, it makes sense because bigger temperature means a smaller peak wavelength. Remember, the wavelength that it's emitting is all wavelengths. The peak one you get from this equation. Wait, is it C? I meant B, my bad, okay. Oh boy. This one is one of those. This is one of those questions where if you see it actually in paper 1, you just should approximate which one it is and then guess. Usually don't have too much time on these ones. It's question 39 especially. A neutron of mass m is confined within a nucleus of diameter d, ignoring numerical constants, which is actually very interesting. What is an approximate expression for the kinetic energy? And let me check that data book. I can just check here because it's faster, I think. So we have this one, this equation, and this equation. But I think this one is more relevant. So delta x, delta p. Okay, let's say it's equals to h or 4 pi. So numerical constants, so we don't care about 4 pi. Interesting. So x times mv equals h, because momentum is mv. And x is our distance, so it's technically d. And now we need the expression for the kinetic energy. So let's move d to the other side, so mv equals hd. Square both sides because you want to get half mv squared. And divide by half. So we get half mv squared times m equals h squared, d squared, and since we don't care about constants, numerical constants, we ignore 2. Now we divide by mass because we don't like it. And we get h squared or d squared times a, if I don't mistake. Wait, can you say that again? How do you get h or d? Okay, let's take it from the bottom up. Because it might look like I just check that. Is it A, by the way? Just to double check. Is it A? Can you confirm? Yes, it's A. Thank you. Now I'm more confident. Okay, we have some kind of neutron. We have nucleus, so this is our nucleus. So we have some kind of protons, and we have some neutrons, and then we have there one neutron. So let's make it. Okay, that's a black color because you can actually see it. Let's make it black. So we have this neutron. We want to know where it's located, approximately. No, we want to know the kinetic energy with approximately, if we know the approximate location. So we know that approximate location is this huge ball. From Heisenberg's principle, we know that delta x, which is plus minus location multiplied by delta p, plus minus momentum, won't ever be bigger than h or 4 pi. I make it equal because let's imagine that we have the perfectly, to base off our approximation, we know where it's located times its momentum. So that's where we start. So I will write it in our terms. So distance is where we know it's confined is d. The momentum is m times v, so mass times velocity like normally. And we ignore the numerical constants, so 4 pi disappears. Technically it should be there, but they didn't care for some reason. Okay, so we have h left, the Planck constant. I mean, I could see the answer that h was there, so it was obviously we couldn't remove it. Now we want to get kinetic energy. What's kinetic energy? It's half mv squared. One way to do it is to square the whole equation, so to get v squared. So d squared, m squared, v squared equals h squared, h squared. So we need to get mv squared, so we divide by, so left hand side we divide t squared and m, so we move it to the right hand side. mv squared equals to h squared over t squared m. And if we should multiply by 1/2 theoretically, but so 1/2, but we ignore the numerical constants again, so we don't care about that. So half mv squared equals kinetic energy, which is our answer. H squared over d squared m, which is a. Hope that answers your question. Okay, perfect. On its journey, the railway engine now travels around a curved track at constant speed. Explain whether or not the railway engine is accelerating. 3 marks. Ooh, that's a good question. And stream is still running, right? Hope it's not lagging. I don't have any dropped frames, so that's good. Love my internet. I don't know why I copied. I don't have anything to say, but write him in. So why is it accelerating? I would say it's accelerating. Why? Because we have from the equation. I'm pretty sure you already answered it in the discussion, but let me try to do it as well. So since we have curved path, so let's say it's a circle. It does have to be a circle. As long as it's curved, we can approximate the circle on a big enough scale. So our train, it moves from here to here. So that's train. And due to this, we have some kind of acceleration. So first of all, we have friction. I don't know whether they would accept it, but it's 3 marks. I don't know what to say for 3 marks if I don't mention friction. So constant speed means we have to compensate for friction. Secondly, we turn. So our velocity was here, now it's here. So we have some kind of acceleration towards the center of the curved path. That's our acceleration, that's our force. So engine has to do some force. I mean, so I would say that there is, because we have friction and because we're on a curved path, so to change our velocity vector. So speed is the same, but velocity is not constant. Change velocity vector, we need some acceleration, which the engine provides. Whew. You mentioned the friction is present, that's why it's 3. I have no idea whether it's it would be required, but 3 marks. Like I would say it's 2 marks for the friction. I can try to find it in the question bank. Give me a sec. If it's not too old, then I should find it. On its journey. How many questions have written on its journey? Quite a lot. Not this one. It's part F. Oh my goodness. Okay, it's not relativistic. It's relativistic. Okay, found it. November 2011. Oh boy. Yeah, let me show you the mark scheme. It's definitely not. I mean, so direction of engine is constantly changing. Yes. Velocity is speed plus direction. Velocity is a vector. Yes. Engine is accelerating as velocity is changing. Yes. So basically, I didn't need actually friction. I'm surprised they accepted 3 marks for just saying that. Or we can say that centripetal force is required to maintain circular motion. Something about Newton 1, Newton 2. So engine is accelerating. Yes. I don't think they would say 0 if I mentioned friction. So they haven't written anything about it. If it's like so many marks, I mean 3 marks is not that many, but I wouldn't expect them to actually give 3 marks for that. That was a bit unexpected for me. So I guess it might be worth mentioning. Okay. I ran out of questions for now. So if you have questions, ask now. Remember your exam tomorrow. It does have to be specific questions, it can be conceptual questions like what the hell is something. Whew. Please don't be the thin film. I did astrophysics option. I remember not much from it. You can probably ask, but I'll probably say I'm not sure. Even though I loved it absolutely. I haven't done it in a year. I actually haven't repeated in a year, unlike many other options. It's not the best quality, but I think we can work with it. Okay. Electrical resistors can be made by forming a thin film of carbon on a layer of an insulating material. Carbon film resistor is made from a film of this blah blah. Diagram shows the direction of charge flow. Resistance is yes, calculate the length, and we found it. The film dissipates a power less than 1500 watts from each square meter of its surface to avoid damage. Calculate the maximum allowable current for the resistor. What? Okay. Okay, so we know the resistance of wire. We know the power. We need max current. I think it's 2 marks. Shouldn't be too hard. So we know that power equation, and I got a pink, let's double check. Yes, that's what I want to do, thank you. So we know that power equation is current square times resistance. We know power, it's about 1500, divided by R, which is 82, equals I. And since current should be squared, then we take square root. And I have calculated here because why not? We guess 4.28, and I mean sometimes you don't even need to understand what happens. You just apply the proper formulas. We know that it's energy. We know something about ohms. I mean the resistance. So apply one formula and get. Thank you, Lily, for being here. I really appreciate your modding. Good luck on your exams. Yes. Which option are answered? How would you approach something like this? At a particular instant in the flight, the glider is losing 1 meter of vertical height for every 6 meters that it goes forward horizontally. At this instant, the horizontal speed of the glider is 12.5 meters. Calculate the velocity. Ooh. Give you answer to the appropriate number of significers. Thank you. How would I approach this question? Most of physics is built on drawing. Okay, we have glider that moves 6 down, 6 forward, 1 down, 6, 1. We know that it's 12.5 now. We know the ratio between them. So for each 6 it's 1, so divide by 6, multiply by 1, you get this one. Pythagoras, you figure out the velocity. Remember the appropriate number of significers. That's literally it. Ah, cheeky people. Okay, so I'm done with this question. Yes. Okay, let's go back to the other question that apparently I got wrong. Yeah, I mean that's gradient. Yes. Boy. Of course, I always do mistakes. I'm a human too, so hope you can forgive me that. Of course, I missed it. Always double read the question. What did I miss? This key. The film dissipates 1500 watts per square meter. Bravo me. So first we need to find the actual power dissipation in this one. And we have width of 8 millimeters, and we found the length of some kind of length. And then we found area. Area times watts, we get the should be, yeah, because it's watts per 1 meter squared, so it's technically intensity. We get the power. From there, that's the one we use the E squared R. My bad. Thank you for correcting me. Yeah, I missed this part. Read it very carefully. Double read the question. Triple read, I don't care. Read it several times. I try to go a bit fast, quick here, so I might miss something. It's being me if I do it wrong. So, where do you get the equation? Yes, formal booklet. Okay. You have like 2 hours and what's minutes if it's HL. Yes. Could you go over the photoelectric effect? Again, I did the revision session, I recorded it, I'll go shortly. More detailed, probably, I don't know how much more detailed, I don't remember. It was in the other session. The link is available, it's both on YouTube and for your own download as sounds. Presentation is available. All should be written in the published in this channel. And okay. Or you can find my YouTube channel, there you'll find the links, all links. Okay, how's the stream going? Stream is up and running, perfect. Okay, photoelectric effect, and I steal it from the Google Slides, my previous presentation. So again, it's HL. Okay, so photoelectric effect describes how we can describe electrons as particles rather than waves, because some of you might think if waves describe photons so good, why would we need particles? And this is one of the experiments that, if I don't mistake, Einstein came up with. Well, I might mistake, so don't quote me on that. So photoelectric effect shows, what is it basically? We have a metal plate, it's kind of like metal plate, is a metal plate. And then we have a circuit, so we have wire, so I'll say ammeter, and some kind of thing that collects electrons. And then we get some kind of light source. That's bad color. So light source. It sends electrons into this direction. Why does it give electrons? Because photons come to the electrons, they give energy. How much energy? It's kinetic energy equals h times the Planck constant times frequency, should be frequency here, not speed, minus the work function. Work function will be given for each material, as different materials have different work function. So it's minimum energy required for electrons to leave the metal surface. So if the energy enough, they complete the circuit, go through the ammeter or the voltmeter, whatever, and we see a reading. So this graph also describes it really good. So given energy of, given frequency of specific light, how much energy does electron gain? So if work function is negative to 4.3 electron volts, then if frequency is not enough to go over the work function, we don't get any electrons coming out. But when it just hits that threshold of a work function, the electrons gain some kind of kinetic energy. They leave the metal plate and complete the circuit. So there are several things you need to remember there, like each photon gives energy to one electron. Intensity doesn't increase the kinetic energy, but it increases the amount of electrons that come out, because more photons, more electrons can come out of it. And calculations. Yeah, several graphs, and I'm not going to go over them. Check book. It's actually not that many, but like voltage and current graph, and this graph right here. It's even more important.
Are you looking at a book or?
No, we have a stream right here. It's posting important files and links.
Oh, I see. Thank you.
No problem. Do I have my volume so loud? It was a bit loud. Scared me a little. Oh boy. Okay, so this question. Electromagnetic forces. Diagram shows two currents carrying wires. Both lie in the plane of the paper. Arrows show the currents. Electromagnetic force on Q is in the same plane as that of the wires. What's the direction of the electric force acting on Q? Okay, so we have to use right-hand rules, and I'm gonna again steal them because from my slides, because I can. And this one. Ignore the writing. So first we have to use the left right-hand rule, so this one. Wait, this one. So since it's P towards Q, we use this rule. So thumb towards the current's position, and then we get the curl our hands in the same direction as B field. So we see that it's somewhere down. So down on this side. Now we have to use this rule to figure out where the force is. So on Q, Q moves to the right. Well, it's moving charges, but so it's current. Now we need to place our middle finger and other fingers to the down position because that's where the magnetic field is. Where force pointing up. Answer should be A if I didn't make any stupid mistakes. Yes, so two rules. Very important to remember. You have to know them both for both SL and HL. Yes. Learn them, how to apply them, and you'll be good. Don't be afraid to do it in an exam. It doesn't look stupid, trust me. It looks more stupid if you get lower grades. I'm not gonna do this question, honestly. Don't ask me. Thin films, I'm gonna say something stupid. I've already gone through this question before. I didn't figure out why. I'm sorry, I don't remember. You have to Google or ask someone else. Okay, I don't see any more questions coming up yet. Any more questions?
There's one about phase change.
Yeah, I know. I said that I'm not gonna answer because I honestly don't know.
Oh, okay. Should I explain?
If you can, go ahead.
Okay. All right. So when a ray goes into a more dense medium, it undergoes a phase change of, I think, 1 pi. Let me get my notes out.
It should be 2 times the distance between the two medium boundaries.
You're really, really low. Wait, let me turn you up. Who's the guy that was talking?
Yeah, the phase change should be the distance between the two boundaries.
Okay, cool. I can't find the notes for some reason.
Yeah, use a small angle approximation because for basically finding the length of the arrows going up and down, and you approximate that as approximately the distance between the two boundaries.
We can come back to it later if you
Oh,
want.
yes. Okay, I found it.
No,
All right. Sorry.
Go ahead.
Okay. Interference between light waves. That like wait, no. Okay, thin film interference is when. Oh, okay. So a light hits a surface that has a higher N than the you know the previous medium. There's a higher N than the new medium, which is what we see here. You know, it goes from air to film, and the film has a higher n. And yes, okay. So when the second film is more dense, like has a higher n than the first film, and then like the ray is reflected, it will undergo a 180-degree phase shift, which is pi. So for J, it does not reflect off of, like it is not wait. Yeah, no. For J, it will undergo a 180 phase change because it is hitting a surface with a higher n than air. But for the rays in the film, they will not be undergoing a phase change because they're reflecting onto air instead of from film, which air has low n, film has higher n, no phase change, no phase shift. So J only, I think the answer should be. Yeah. Is that the right answer?
Yeah, it's J only.
Okay. Well,
Thank you very much. Wonderful explanation.
I'm sorry, I suck, but
No, it was wonderful. Definitely better than me. So, perfect. Okay, so let's go to another question then. Hopefully I can answer this one. Thin film is really hard and they didn't really ask questions about it lately, so it's quite interesting as well. Oh boy. And P and Q are 2 points on a standing wave. R and C are 2 points on progressive traveling wave. Oh boy. Which of the following gives us the relationship between the amplitudes of each pair of points? Yes.
I can, if or can't. Oh.
I'm just giving you a second to think. If you really want, you can explain it.
No. You go ahead.
Okay, thank you. So, standing wave. In a standing wave, we have nodes and antinodes where the... Let me draw it. That was horrible. So, if I don't mistake, these one are nodes. So the amplitude is 0 because they simply don't move. It's very good to see a picture if you like Google something like standing wave on a string. You can actually see it very clear. And antinodes where the amplitude is max. What's in between? They move not with the same amplitude, they move with smaller amplitude. So for standing wave, it's definitely different amplitude, so it's B or D. Now for progressive wave, wave is moving, the particles move up and down. But the wave moves as well, so amplitude always, the position of R and C always changes, but amplitude is constant. So if I don't mistake, it's B. And can I check it? Who's it? Gabriel, can you please check if it's B? That's B. Well, it has to be B or D for sure because standing wave does have constant amplitudes on all points except for nodes and antinodes.
It's B, for sure.
Yeah, it's B. Yeah. Okay, I was right thinking. B, yes. Yeah, for traveling wave, the wave moves, so the position of R and C points always changes, but the amplitude is constant, unlike standing wave. I can actually probably find the video right now. Actually, it's perfect because I can show it on the stream. Standing wave of a string. Mm. And let's move this guy. And if I get it here,
consistently reflect destructively interfere point. Now the
as you can see, the amplitude, the antinodes are here and the nodes are here.
waves that
So as you can see,
reflect
so for example, this is P and C points, they don't move with the same amplitude.
that come down and reflect
So why do
destructively
you have to
interfere
walk
with the
here?
incoming waves right here. And that's called a node. I can
Yes.
touch it and it still is working. So the node is not moving. Here it's moving up and down.
Yeah, I think it's good enough explanation, demonstration. How come R and C are the same amplitude? Because it's moving wave, so was one point here, then it moves right here, so then at some point it's like this. Yeah, it's horrible drawing. We can say that the amplitude, the wave like moves like here in the horizontal direction. So amplitude will come to here. So C will also get the amplitude, full amplitude. Okay, perfect. Oh boy, this one is fun. It's probably one of the favorite questions of all physicists because you actually have to think non-standard XY plane, but redraw it. So the easiest way is to actually not use this coordinate system X, Y. It's not really straight, but it's supposed to be straight, vertical, horizontal. But this one. So we have to change components for W. So R is equal to V times sine or cos or theta. Which one is it? Think of critical angles. So if the angle is here is 0, then R is equal to W. So it should be cos. That's the easiest way to figure out without drawing all triangles. Yeah, if it will be 0, then it could be tan or sine. That's another question. Here it's cos, obviously. So this one is W cos, so this one is W sine theta. Is equal to friction force, because those are balance force, those are the only horizontal forces. Well, in our case, horizontal. So this is mu times R, which is V times cos theta. Cancel out. One divided by another, then theta equals mu, which is our coefficient. That's all. I know you answered 10, but then you like sine over cos, so this one. Yeah, please use discussion. Okay. Well, critical values are really important to think. Like, because sometimes the equation doesn't make sense when you think of critical values, so that's how I make sense of math usually. It does make sense on critical values. No, it doesn't, so maybe I made a mistake somewhere. So that's, yeah. Oh boy. Yes. More questions? Or did I skip a question? Oh, sorry. Oh boy, I skipped. Sorry, my bad. It's a bit easy to miss it, like when it's called like similar stuff. Oh boy. A large cube is formed from ice. A light ray is incident from a vacuum at an angle of 46 degrees to the normal on one surface of the cube. The light ray is parallel to the plane of one of the sides of the cube. The angle of refraction is 33 degrees. Calculate the speed. Yes. Show that no light emerges from side A, B. What? Okay. First I thought maybe it just doesn't reach because it doesn't reach like this, but it doesn't seem to be the case. So we have two angles. We have two parallel angles, two parallel lines. These two parallel lines. Actually, I should probably use other color. I already got two pinks. Critical angle. Okay, it's probably critical angle, that's what I think. Okay, so we know we have two parallel lines and a line that crosses both of them. What does it mean? It means this angle and this angle are equal, so 33 degrees. Circle quadratic 33. And this one is, so we have something coming at 33 degrees. Now the question is it a critical angle? So from this side, it would be 90 minus 33, it's 57 if I don't mistake. The angle of recursion. Okay, I might be a bit dumb here. I mean, obviously it's not coming out because it's 57 degrees, but how do we show that the critical angle is 57 degrees? Give me a sec. I mean, unless you, of course, know them, ping me, something I would say. Yeah, but if you do one of the thetas as 57, what does it actually show? Let's figure out without Marsky first. I mean, okay. We know velocity, right? And we know angle. Maybe if we put angle of one and then we figure out angle of another and figure out it's bigger than sine. That might be the case actually. So sine of theta 2 divided by, can you please give me the answer to A1? Because I probably need it. So sine of 57 degrees, I think you put 57, equals V2, which you don't know, and then we put its light 3 times 10 to the 8. .3 times 10 to the 8. Okay, so 2 points. Yeah, we do correctly. I should be correct. Wait, no, 1 is same angle. Should be 3 times 10 to the 8 divided by, what was it? 2.3 times 10 to the 8. So 10 to the 8 cancel out. Right. So we get 3 times divided by 2.3 multiplied by sine of 57, and I of course have it in radians because who uses degrees? And we get that sine of theta 2 is where bit flanks for 0. Wait. Yeah, right. And we cannot do arc sine of that. That's why no no, light is refracted. Yes, all light is reflected. Because we cannot do arc sine of bigger than 1. Right? I'm not being stupid right now, right? Yeah, it's math error. Correct. Back to radians. That's all. So you have to remember some geometrical properties of two parallel lines. No, I did V1 as light outside of the block, so I did them opposite way. I wrote it right, but put the wrong value for V1. I give up on this question. Yeah, simple harmonic motion is definitely not the easiest ones. It's probably HL as well. Okay. Excuse me. Particle of mass m oscillates with simple harmonic motion at angular frequency omega. The amplitude is A. What's kinetic energy of the particle when it's halfway between the equilibrium point and 1 extreme watts? Okay, let's answer the easy question. How did I find the new speed of light? It was I was given the answer from the original person. You can figure it out by the same question because you were given 2 angles and 1 light. Let's try to figure out this one. Particle of mass m oscillates with simple harmonic motion of angular frequency omega. The amplitude is A. Okay, so we have some kind of particle. Okay, probably not string, but okay, so simple harmonic motion. What's kinetic energy of the particle when it's halfway between the equilibrium position and 1? Okay, got it. So we have, oops, that was a bit too much. So we have this one, and we are halfway. So this one is same distance. Okay. Let's try to find it. Maybe I haven't done it in a long time. Okay. Energy kinetic. What's the formula for it? Half omega amplitudes. X0 is pretty sure is amplitude. Squared minus our position. Our position is half of that. Of half amplitude squared. If we do the math, then it's 1/4, then we have 3/4 left, and 3 m omega. I think it's B. Is it B? It is a cell question. I'm not sure because the formula that I use is from HL topic. Who was the question? Coffeeholic. Nice name. What's the answer for your question for particle oscillating? I feel like it has to be HL. Where did you take it from? Like what year? Because before 2016, I think it was SL as well, but now it's HL.
It's November 2015. It's November 2015.
Yeah, November 2015 is before the new syllabus, so it has to be HL. Alright, it was written right there. I just copied, my bad. Yeah, that's HL question now, yes. So if you didn't get it because you're SL, that's okay. If you're HL, it's in the data booklet, HL section 9.1. Yes. More questions? Okay, let's do last questions throw it away because I have to end it right about now. So you have literally exam tomorrow. I'm surprised you don't have that more questions.
Maybe we prepared well.
Yeah. Well, some of you definitely did. I'm not sure if everyone. Okay, we got some last questions. Okay. Just a quickie. Where was the right here? And the spherical body has absolute temperature T1. The surroundings are kept at a lower absolute temperature T2. What is the net power per unit area lost by the body? Oh. Doesn't it really... I mean, the main question here is, does it depend on the outside surroundings? Okay, I got... Never mind, ignore that. I honestly don't remember. I mean, obviously it's power divided by area equals to the constant times temperature to the fourth. Spherical body. Who's microphone on? Please mute yourself unless you talk right now. I think it's B because in the proton it's constant size. Wait, what was other? Honestly, I don't know. It has to be B or C. Because obviously it's lost temperature of the body. I don't remember if it affects house surroundings. I think it's B, because I don't think it should. I got a pink. Is answer C? I have no idea.
You can look in the formula booklet in thermal energy transfer. There's literally a formula for it, right?
But the question is, does it depend on the surrounding temperature?
Yeah, but like for C, you look at the formula and then I don't know how to explain it. Like, okay, never mind. Okay, if someone else can explain it, they'll probably explain it better than me. So.
What question is that?
The spherical body question 36. Posted by Oh Boy. Oh Boy, it's C.
Yeah, wouldn't the surroundings would matter because it says the surroundings are kept at a temperature of T2.
Yeah, but maybe they just did it to make us confused. I would say that should matter, but I don't remember why. Okay, let's see then.
Why wouldn't it lose power quicker, actually?
Because I don't think power radiated is based on a temperature gradient.
Does somebody have the equation? Because I don't actually have the packet in front of me.
Well, the equation is power over area equals constant times T temperature to the fourth.
Okay.
That's just the surface temperature of the black body radiator.
Yes. The question is, does it depend also on the surroundings temperature? From the logical sense, it should be yes, it should depend. From math sense, I have no idea. But apparently it does depend, so yeah, okay, let's see. I don't think there's much to point to discuss. Okay. An isolated hollow metal sphere of radius r carries a positive charge, which graph shows the variation of potential V with distance x from the sphere of the center of the sphere. I actually surprised they ask such question. It's completely university level. It's something that I do and I should know, and I also don't remember. It's not A for sure. I think it's B. An isolated hollow metal sphere. If it's metal sphere, all of its charges stay on the outside of the sphere. They are never inside, due to Gauss' law, which you don't know. Voltage potential, however, yeah, voltage. Okay, I don't want to lie here. Let me double check in my notes. This one's
Actually, yeah, it should be B, because if you draw a the electric fields, then the separation between them should be constant, shouldn't it?
I mean, it has to be constant potential because there is no electric field lines inside. The question is if it's on the top or starting at 0. It is at the top, it should be B, yes. I'm trying to find out why, because I think that's a good question and I'm supposed to know that. Give me a second. Okay. Yeah, here it is. The electric field would be the D graph. Just it might be a bit sharper because it's R squared. It's okay, it doesn't go 0, it'll be below X. It's B here because, yeah, well, obviously this one is quite obvious. Inside it has to be constant because there is no electric field inside. I honestly don't remember why it is, and I'm surprised they asked that. Okay, let's check all the pings.
Yeah, in my notes I just have this constant equal to the potential at the surface.
Yep, B. Check my explanation above. Because the surroundings have a lower absolute temperature, the heat moves out. Heat loss moves from hot to cold, so heat loss will be higher absolute minus lower absolute. I mean, yeah, it makes sense, yes. Okay, that's probably correct. Hollow sphere is just, yeah, metal sphere. Please don't discuss. Okay, post your last questions because after that I'm gonna go because I have my own studies to do and stuff. Hope you can forgive me that. This question is okay, it's just calculations. Unless it becomes super hard right now. But 1 kilowatt heater supplies energy to liquid of mass 0.5 kilograms. The temperature of liquid changes by 80 Kelvin in time of 200 seconds. The specific heat capacity of liquid is that was average power lost by the liquid. And never mind, that's not the big. And so we have some kind of cut. water, and we have energy supplied. So the question is, how much difference is energy supplied and lost during the time? So basically power loss. So 1000 times 200, what is it? 1000 watts, that's joules per second, times seconds, we get amount of joules that we supply to the liquid. So 200 kilojoules. Now we use the equation of how much does the temperature change, theoretically. Mr. Katz. So 0.5 kilograms times 4 kilojoules, because that's our C value, times temperature of times 80. That's 2160 kilojoules. So that's energy that the liquid received by using how much temperature changed. So what's the difference between supplied energy and energy actually gotten by the liquid? 40 kilojoules. That's our energy loss. So now we need to find the average power lost. So we divide by number of seconds. And we get our answer. If I don't mistake, that should be it. So 40,000 divided by 200. I'm too lazy, so I'm just going to find my calculator. I lost it. Nice. Let's use another calculator. 40,000 divided by 200. That's 200 watts. So amount of joules lost per second. It's 200. Yeah, okay. I got the same answer. Good. Okay. Last question, anyone? If not, okay, one. Okay, last one. Come on. You can still ask in the physics channel. I'm not sure that you'll actually reply because someone else probably help.
Oh,
Yes.
do you guys want me to go through some theories maybe afterwards? If Fifth ROM hasn't already done that earlier.
I mean, I had the previous revision session, but it doesn't mean that you cannot do it.
Oh.
I mean, I think it's better if you do it, because you can maybe go through differently or something.
Yeah.
Just ask people. Like write in
Yeah,
discussion.
just general theories, I guess. Just, I guess, everything.
Unit of energy density. So, well, obviously it's joules, and since density is, oh my goodness. Okay, my brain is completely having. Density is meters cubed. Yes, it's mass divided by volume. Thank you. So it has to be B, I guess. Or is it? One more, sure. To be A. Maybe I'm completely. Give me a second. Wait, what? Energy density has to be joules per meters cubed. What the hell am I thinking? They don't even have that answer. Tapioca. Why did you take it? It has to be joules per meters cubed. Specific energy is joules per kilogram, but they ask for energy density, right? Energy density, yes. Okay, strange question. One more quick question. How do you know the direction of wave propagation from a graph? Depends on graph. I know it sounds stupid. I mean, okay, if usually it moves obviously to the right because it should be given actually the speed of it, like where it's moving. If it's like, okay, I'm gonna easily make a mistake right now, so please correct me if I'm wrong. I always forgot which one it is. If you have x graph, so displacing graph, it's a snapshot. So usually they have to write velocity in that direction. If it's time displacement graph, then it's amplitude, then it's not even moving, it's just one. It's not just one particle, it's like moving in distance. Is the first review session going through the whole Oxford study guide? No, I made my own presentations there. It was another TZ1. TZ1, I think they did Oxford study guide, if I'm not mistaken. Correct me if I'm wrong. Yes, energy density does make sense. Yeah, that's why I was confused. I was like, am I being like stupid right now? Perpendicular to the wavefront. I mean, yeah, from a graph it depends. Which is the unit of electrical energy in fundamental SI units? Now is the question which one is SI units, and that's very easy to forget, so I forget that one actually as well. Electrical energy, what? I mean, electrical energy. I don't like that they add electrical energy. Should be either just energy or something. I mean, energy is just joules. Oh my gosh. Joules is newtons times seconds, and newtons is kilograms meters per second squared times, wait, did I say seconds? Meters times meters, so it's squared.
Wait, isn't joules Newton meter?
Newton times meters, yes, I fixed it. Thank you. And is that it? Electrical energy.
Do they maybe mean voltage?
The answer for that should be yeah. No, it is actually C. Yeah, I thought of voltage.
Oh, can I say something?
Hello.
Hi, Ron.
Yes.
It's meant to throw you off, I think, because regardless of what kind of energy you have, they're all measured in the same unit,
Yeah,
which is joules.
that's why I'm confused by the question. Like, it should be just joules.
Yeah, the answer for that is C.
Yeah, okay, I did see, yes. Thank you.
Mm-hmm.
Okay, so I think that's all. Guess we round off. No more questions, no more like last minutes. Help, save, panic. Oh boy, is writing something? Oh boy. And Tom. Yeah, okay, then it's
Thank you.
Yes, welcome. I wish you good luck on your exam tomorrow. Again, I did the whole revision session of the whole syllabus. I don't know how much it's gonna be helpful right now, but it's there if you need it. Definitely, if you want go through theories together, it will help you a lot for your own stuff. And good luck.
Yes.
Thanks, bro.
Welcome.
All right. To help you guys remember it better, I'm gonna moan out all the facts. I'm kidding. Okay.
Okay.
Wait.
Goodbye,
Where?
guys.
Bye bye. Let's go
Later,
through. Let's go through.
Okay, stream guys. Hello, hello. And let's change. It won't begin shortly. We are ending. Thank you for coming. I wish good luck on exams, and if you're watching it later, good luck whatever you're doing. Stay awesome, and that's